In this lesson, we're going to learn to factor trinomials with a coefficient. On the board, I have a list of the three factoring methods that we've already learned, now with this fourth method in the sequence in which we'll look for them. So I have these up here just to remind you that whenever you're factoring, you do need to follow these in order, meaning we're always looking for a GCF first, and then if a GCF can be pulled out, or even if it can't, we look at with what's left. Can it be factored by grouping, which would be potentially a polynomial with 4 terms or more? And then if our polynomial has 3 terms, then we're going to look to one of the trinomial methods for factoring. So you already know the trinomial without a coefficient method, and today we're going to look at the trinomial with a coefficient method. Just so that you are clear on the difference here, a trinomial without a coefficient is a trinomial where the highest degree term, meaning the highest exponent, has an understood coefficient of 1. So it's really usually not there because there's no need to write the 1. That's why we'll say it's without a coefficient. A trinomial with a coefficient is a trinomial, meaning 3 terms in the polynomial, where the highest degree term has a coefficient other than 1. So 3, for example, in this case. This would be 3x squared plus 8x plus 12 would be an example of a trinomial with a coefficient. And this will have a slightly different factoring method than the trinomials without coefficients. Just to review, because our method for today will use 2 of the methods we've already learned, we're going to practice this problem. So here we have a trinomial to be factored, and this is a trinomial without a coefficient. There's no coefficient on the x squared. It's understood to be 1. So remember, with trinomials like this, we will start with the last term and finding factors of 12 that add up to our middle term. Add up to 8. So you can go through, there's 1 and 12, but they won't add up to 8. There's 3 and 4, those add up to 7, not 8. So the factors of 12 we're looking for will be 2 and 6. Once you determine which factors you need and the signs that they need to be, then to fill in the first slots of your binomials, you just take the square root of that first term and fill that into the first slots. So this trinomial factors to x plus 2 times x plus 6. Let's also review the grouping method. So with the grouping method, you need at least 4 terms, or 6, 8, and so on in even increments. We're, for our class, just looking at polynomials with 4 terms when we're doing the grouping method. So with the grouping method, look to your first 2 terms because all 4 do not share a common factor. So we'll just focus on the first 2 terms alone. And see, do they share factors? So you can see 3xy and 15x do share a 3 and an x as factors of those terms. So as long as our first 2 share a common factor, then we can group the first 2 and the last 2 as is. There's no need to rearrange the order. And we will now pull out the GCF from each of these pairings. You do want to make sure that the signs make sense or will match up. So I've got a positive and a negative, a positive and a negative, and so as long as that's matching, you are good to just pull out a positive 2 here. If for some reason like this was a negative and that was a positive, we'd want the sign switched to match the first binomial, so you might pull out a negative 2 in that case. However, our signs are good, so we don't need to worry about that. Okay, so when I divide 3x out of the first 2 terms, it leaves me with y minus 5. Bring out my plus 2 and divide the 2 out of the last 2 terms, leaving us with y minus 5. Again, remember, you want this to be the same. Once you notice that one binomial that is the same, that is the GCF now of this expression that comes out. So you will write it 1 time, and then you will write the remaining 3x and the plus 2 together in a binomial to make up your last or the rest of this factored out binomial. So y minus 5 times 3x plus 5 are the factors of 3xy minus 15x plus 2y minus 10. And we use the grouping method for 4 terms. So the reason we review this is because factoring trinomials, I should say with a coefficient, with a coefficient, we are going to combine the grouping method with the trinomials without a coefficient method. So you'll see that today's method is really not too much new. It is a combination of the two methods you already know. Okay, so just to review, remember that for trinomials without a coefficient, we wanted to find two factors with a sum of the middle term and a product of the last term. So we saw this example already. We looked for two factors that added to 8 but multiplied to 12. So there's going to be a slight tweak to this with a trinomial with a coefficient. So in a trinomial with a coefficient, we will need two factors that have a product of the coefficient in the last term, but still we're looking for a sum of the middle. So the only difference is what we're finding products of. So for example, if I had the trinomial ax squared plus bx plus c, what this means is that we would find first what a times c equal. Once you find the product of a and c, so we would want a times c, all right, we'll call that ac. We would need to look for factors of a times c that add up to be b. So this is looking at it algebraically. Let's look at it with numbers. So here's our first example. We've got 7x squared plus 29x plus 4. This is a trinomial with a coefficient. So your first step is going to be to come off to the side, and you're going to not just find factors of 4, but we need to do 4 times 7, which is 28, and we need factors of 28 that will add up to our middle term of positive 29. So it's similar, but the number we're finding factors of is found by the coefficient and last term. So we multiply the first and last term, and you can ignore that x squared for the most part. We're really just focusing on the numbers there. So that's 28, and we want factors of 28 that have a sum of 29. So those factors will be 1 and 28 in this case. Once you find the factors of 28 that add to be 29, we're going to use 1 and 28. And the way we're going to use them is we're going to rewrite our trinomial that we're given. So we're going to rewrite 7x squared, bring that down. But instead of the middle term as 29x, we're going to break it apart into a plus 1x plus 28x. And then have the plus 4. So we break apart our middle term into the two, my ears are going all over. Anyways, the two factors we found. So at this step, we're just writing this polynomial a new way. We're not changing the value of anything here because 28x plus 1x would combine to be 29x. We break it apart so that now we have a polynomial with 4 terms, and we will finish factoring this polynomial now with the grouping method. So we will group the first 2 terms together and the last 2 terms together and finish out as if this was the grouping method. So 7x comes out of the first 2 and a plus 1 comes out of the second 2, leaving us with 7x times x plus 4 plus 1 times x plus 4. We want this to be the same, so we are good there. And those make up the 2 binomials that this will factor to. So you can see how it's a combination of factoring trinomials without a coefficient and the grouping method. Let's do some more. So this is not switching for me. Okay. Okay, I got this to switch. All right, so here's our next example, 2n squared plus 7n plus 5. Here is another trinomial with a coefficient. The highest degree term has a coefficient other than 1, it's 2. So first order of business is to multiply that 2 by the positive 5 to get 10. We want factors of 10 that add up to our middle term of 7. So factors of 10 that add to 7 will be 2 and 5. 2 times 5 is 10. 2 plus 5 is 7. At this point, we then rewrite our trinomial, but break that middle term apart into two terms that would combine back to 7n. And I didn't so much talk about this on the first, but just whatever the variable is with its exponent, you just use that variable combination, whatever it might be, for both terms in the middle. So we're going to break 7n into a 2n and a 5n. They're both positive, so have plus signs there. From here, we finish by grouping. So group your first two together, group your last two together, and factor out the GCF from each grouping. So from the first two, we will be able to pull out a 2n from both terms. For the last one, we're able to pull a 5 out of both terms. When we divide 2n squared by 2n, we're left with n. 2n divided by 2n is 1. And 5 out of 5n is n. 5 out of 5 is 1. 5 divided by 5. And so our polynomial, or trinomial in this case, factors to 2n plus 5 times n plus 1. Remember, you can always check if you factored correctly by re-multiplying this out and seeing that you end with 2n squared plus 7n plus 5. So here's our next example. We've got 2n squared minus 7n plus 6. Start by finding factors of the coefficient and the last term. So 2 times 6 is 12. We want factors of 12 that add to be a negative 7 in this case. So two numbers that multiply together to be positive but add to be negative means they both need to be negative values. So the factors of 12 that add to negative 7 will be negative 3 and negative 4. Once you've determined those two factors, we will break the negative 7n into the negative 3n and the negative 4n. And from here, we finish by grouping method. So group my first two, group my last two. Remember, with a minus here, we'll include the minus and put a plus in between the two. You can see this one's positive, this one's negative, this one's negative, that one's positive. So that indicates that we're going to need to pull a negative out of the second grouping. But out of the first, the GCF is n, which leaves us with 2n minus 3. Bring down the plus sign. Then we're going to pull a negative out so that our signs match the first binomial signs. And pull out a negative 2, making this now a positive 2n. And 6 divided by negative 2 is negative 3. This ensures that our signs match, finishing with n minus 2 times 2n minus 3. Okay, my changing of slides got mixed up and I accidentally skipped example 3, so I'm just going to go back to it real quick. So multiply coefficient by last term to get 30. Factors of 30 that add to be 17 are, well, you could say 6 times 5 is 30. That's not. 1 times 30 would be 31 if we added. So the factors of 30 would be 2 and 15 that add to be 17. Once you get 17, you'll break apart 17x into a 2x and a 15x, and we finish by grouping. Oh, sorry, I forgot the 3. Okay, so 5 came out of the last, and a 2x came out of the first, leaving us with 3x plus 1 inside, both of those times 2x plus 5. All right. Let's now look at this next example. Here we have the variables slightly different. The highest degree terms, actually there's like a tie for it of a squared and n squared. Regardless of the order you put this in, both of those have coefficients. So We will carry on as usual with starting by multiplying the coefficient by the last term's coefficient. So 2 times negative 18 is negative 36. And we need factors of negative 36 that add to be negative 9. So once you find the factors to be negative 12 and positive 3, multiplying to give negative 36, but also adding to give negative 9, you'll break apart your middle term into one with negative 12 and one with 3. Now, when you do this breaking apart, you will just use whatever the variables are on the middle term. You'll use that for both terms when you break it apart. So I just give it a negative 12an and a plus 3an. The 2a squared you copy, the negative 18n squared you copy, just as is. Okay, so from here, we group, and hopefully you're getting quicker and more comfortable with grouping. So if a 2a comes out, that is leaving us with an a minus 6n. Here, a 3n can come out, leaving us with an a minus 6n again. So 2a plus 3n makes up your first binomial, and a minus 6n makes up your second. All right, that is the end of really our practice for this. Here I just have a quick review of ordering the steps. So remember, the first step is to find the product of first and last terms. Once you've done that, find factors with the sum of the middle, complete factoring by grouping, and rewrite the middle. Oops, sorry. This one goes next. Rewrite the middle term as 2 terms, and complete factoring by grouping is the end. So this is the order in which you should follow for factoring trinomials with a coefficient. Okay, lastly, we're just going to go over a quick way that you can identify if a trinomial, regardless of it having a coefficient or not, would be even factorable at all. And the hint here is to look at your exponents. So you've seen a lot where it's an x to the x squared, then an x to the first, and no x on the last term. What you should do when you're trying to determine if a trinomial can't even be factored at all is look for the exponents on the ends of your variables to be even. So the exponent on the variables have to be even on the ends. So your terms on the ends should have even exponents on those variables. And the middle terms variables exponents should be half the sum of the ends. So I could technically put an x to the 0 here, because anything to the 0 power is 1. So if I look at it, my end exponents are both even or just non-existent. And if I do 2 plus 0, add the exponents, half of 2 is 1, which is my middle term's exponent. So this means that this trinomial could be factorable by the variables potentially. Then you would carry on. Now, if for some reason there are not factors of 3 times 6 that add up to 11, okay, then maybe it would be prime from there. But by the variables, this one would be factorable. Next, we can look at this one. So here, my highest degree term and my lowest degree term have an odd exponent on one of them. So right away, if you see an odd exponent as your highest degree, that means that that trinomial cannot be factored. It's considered prime. So this is a really nice way to quickly identify a prime polynomial. Our next one, the ends exponents are both even, which is good. And then to check the middle term's exponents, what we would do is add 2 plus 2, the ends exponents, which is 4, and take half of 4, which is 2. Now, that 2 tells us what the sum of the middle term's exponents should be. So 1 plus 1 is 2, so this all works out. So it's possible that that one can factor. And lastly, here we have a trinomial with the highest degree as an odd exponent, so it will not be able to factor. When I say it won't be able to factor, this is assuming that you have looked for a GCF and could not pull a GCF out. Once you've looked for the GCF, you can use this exponent method to determine if it can go further or not. So just to recap, without a coefficient, trinomials without a coefficient, all you're doing is taking the product of the last term, ignore that x to the first, or x squared at the beginning, and then find the sum of the middle term. Those factors should have a sum of the middle. If it's a trinomial with a coefficient, that difference is to find the product of the first coefficient and the last term. So that's the only difference. You're still finding factors that add to your middle term. Lastly, there are some practice problems here that you can work out. I would just recommend pausing the video, and then when you're ready to check them, I'm going to just reveal all the answers at once. So when you're ready to check all of these, you can click play. So you can pause now. All right, so you're ready to check. And these should be what you got for your factors. So just a quick note here with this one. Remember I said, okay, if you notice the n's exponents are odd, that could mean it's prime. However, you can only use that exponent trick if you have already pulled out a GCF. And in this case, once you pull the GCF out, that means it's factored. If you do even just the first step, you can pull a GCF out. It can be factored. And this one even goes further. The last one, just there wasn't a combination of numbers that added to 7 when you found the product of 4, 8, and 18. And that is the end of our lesson.